overall. Overall, this is a base computer system that is interactive. You can interact with the system that can help a person or a group to make decision. So in the middle, we will see that in the middle of nothing, even without internet connection, you can use this software because you can install this software also on your cell phone. The important is not is that it is not a Mac or Apple device, because those software does not like Apple device, because as you know, Apple does not like the free of charge stuff. They want everything paid. So anything else you have, it will work. Where do you find a decision support system inside an organization? Inside an organization, any kind of organization, private, university one, academic one, public one, military one, you have the strategic level, you have the management level, the knowledge level, and then you have the operational level. There is not a level that is more or less important than the other one. So a great boss is nothing without the workers. A great boss collapses without the workers. So it means that we need all the level functioning very well. And inside the management level, you have two sub-levels: management information system and decision support system. Let's see the difference. We will work on the decision support system. Decision support system, what kind of problem solves? Non-structured problem. The management information system solves only the structured problem. The user of DSS can be individuals. We will start to work with the software alone, and we will end on Friday to work with the software in group. We will finish the module this week. This is why we wanted you in class, because Friday we will do the simulation and the report. You have to deliver by lunchtime, and we will evaluate it. So we will start today, we will finish on Friday. No homework. You will do the homework in class during the course. And we will have one day hotspot and Aloha, Wednesday biological with Chem, and then tomorrow and Thursday, we will do tabletop exercise. So it's 2 days of training with software, 2 tabletop, and on Friday morning, we will use the software, you will deliver the report, and you will close them up. So no additional homework for that. Okay? The support here is for people that still have to make a decision. Sometimes people can be replaced for the MIS. The emphasis of the DSS is on the decision, on the MIS on the information. The approach is making interactive report with MIS regularly report. What are the factors? Speed. DSS is a type of system that gives you fast reaction to user request. MIS are slower. Output, screen-oriented. We will create map at the end of the simulation. MIS printer-oriented, so those goes more on the report part, on the written part. And the development can be short with user involvement, MIS long without user involvement. So we will work on DSS. The solution type that we are looking for, I put the microphone so everybody can listen, okay? The solution type Better? Yes. Okay. The solution type we are looking for is a satisfying model. We want a good, but not the best solution to a problem. Why we want a good solution, but not the best solution? Why in an emergency we want a good solution, but not the best one?
Because the time.
We have to consider the time. Exactly. So you can have very precise forecasting simulation coupled with very precise numerical simulation, but it takes time. If you use software like Console Multiphysics or Fluent, those are very precise. You will see a level of results that is very similar to the real cases scenario. But in order to complete a simulation, it can take 1 week, 2 weeks, 3 weeks, just for one simulation. Here you will have a simulation in seconds, but the results of the simulation is overestimated, which is fine for us because we do prefer advise a larger number of people rather than advise a lower number of people. But we have an answer from the software in seconds once we have insert all the data inside, okay? Blah, 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 blah. Okay. What kind of capabilities have the DSS? Can solve semi-structured or unstructured problem, complex problem wherein relationship among data are not always clear. The data may be in a variety of formats and are often difficult to manipulate or obtain. If you look at this definition, it fits with the emergencies one. It is exactly what you have during an emergency. Okay? I won't go further on the theory part, but we will start with the practical one, okay? What kind of model do we use in hotspot? So let's start from hotspot. We use a Gaussian model. So now it is time for you to open hotspot. Open the computer and open hotspot. If you didn't install hotspot, you go on Google, write on Google hotspot radiation. Oh, grazie. And if you click on hotspot radiation, the first link that you have is hotspot health physics code for the PC. You click on it, and you can find the latest version of hotspot is available here. You click where it is reported here. You fill a form. So guys, how many persons did not install hotspot? How many persons did not install hotspot? Everyone has hotspot on the computer. Okay, you have to install it. Okay. Can somebody that has hotspot installed help those who have not hotspot installed to install hotspot? Mentre ci siete vicino e l'aiuti così finiamo prima. Can somebody help who has not hotspot? Vi mettete vicino a uno che ce l'ha e ve lo installate, così cominciamo. Grazie. I will give you 10 minutes to install it. Let's wait a little bit that everybody will install it. Okay? Nel frattempo, buongiorno. Buongiorno.
Buongiorno.
Good morning.
Good morning.
Guys, just a few persons are completing the installation of hotspot, and then we will start the exercise, okay? So I kindly ask you to be patient for 5 minutes.
No problem.
Okay, guys. If you still have not hotspot, don't worry. Just sit close by a person that has hotspot, okay? You can work also in 2 person with 1 computer, no problem. Okay. So, as you can see, this is the graphical interface of hotspot. If you click on the title in bold that you find in the upper part of the software on this screen, all these pages that open are called tabs. So one page is one tab. The technical word is tab. So we have 6 tabs: models, source term, meteorology, receptors, setup, and output. Okay? First of all, once you start, you have to go on setup and you have to correct 2 values. On the upper part on the right, on your right, there is distance units. You have to add metric, not English. And then on radiological units, you have to add international system. We will not work with the classic system. We will not work with the American units, inch, I don't know, nails, hair, and so on. We will work with the metric one, which is easiest for all of us, okay? So first of all, you go on setup, then we will go back on setup. But you go on setup and you click on international system and metric. And then we go back to model. Regarding the model, we have two families of model. The first family is atmospheric dispersion models. And the second family is special purpose programs. Among the atmospheric dispersion models, there are two subfamilies. The first group is plutonium, uranium, and tritium accident. So if you pick one of these first subfamily, you cannot choose other radionuclide rather than one that is already setted. So if you go on plutonium explosion, the only radionuclide you are going to use is plutonium. If you go with uranium fire, you will have a fire with the dispersion of uranium. So if you want to use radionuclides different from plutonium, uranium, and tritium, we have to go to the general atmospheric dispersion model, which is the second subfamily, where we have general explosion, general fire, general resuspension, and general plume. Then you have special purpose programs. We will see it in a second moment, but basically we can simulate the explosion of a nuclear bomb, okay? We can do the calibration and lung screening. It is important if you are going to design a laboratory activity where you think to use a radioactive source. So these special purpose programs can help you to set the safety parameters inside the lab. And then you have radionuclides in the workplace. In this case, if you are going to operate in open or closed environment where you think to use a radionuclide, you can make some simulation to have some information before starting the operation, okay? We will start with the general explosion module. Once we have set the models, and we will start with the general explosion, we have to go to source term. Now that we are on source term, we can, first of all, select the type of radionuclide we want to use for this explosion. So why do we use a general explosion model? We use it in two scenarios. If you have an accident and the explosion is connected to an accident and it happens in an area where radioactive sources are present, or if you want to simulate a small dirty bomb, but just a small one, because you can set a small amount of explosive explosive weight. So if you click on change radionuclide source term, a second sub window will be opened. And here you have two buttons. The blue button is to select a nuclide from the library of hotspot. In this case, if you go on the library of hotspot, you will have a lot of radionuclides, but you can select only one radionuclide. What does it mean? You have the explosion plus, during the explosion, the dispersion of one radionuclide. If you go on the second button, In the second button, you can upload up to 50 mixture of radionuclides. So if you want to simulate one of the models that we have in the first tab, explosion, plume, dispersion, whatever you will use it, and you go on mixture, you can add up to 10, 15 radionuclides. And on the user guide of Hotspot, user guide that is available for free in the home page of Hotspot, here, Hotspot user guide, you can download it, you can read it. There is instruction on how to create the file that you have to upload on Hotspot to create the mixture of substances, okay? So you have to create okay. You have to create a txt file. You can copy the example that is on the Hotspot user guide. You change the parameters of the radionuclides, and then you add the mixture. Once you arrive to 50 mixture, doesn't mean you can add more. You have to cancel some mixture and you can add some other one. Up to 50 you can add for free. If you want more than 50, you have to cancel the one that you are not longer using and you add the new one, okay? But we will start today with one substance. So if I click on select a nuclide, there is a pop-up window that opens up. And if I click on the black arrow that point on the bottom part of the screen, as you can see, there is a long list of radionuclides, and this long list of radionuclides where can be used inside the explosion. So you have radionuclides, you have different isotopes, and then you have this letter FMS. FMS is fast, moderate, and slow dilution in the blood of a human being. So you can simulate the same isotope with a fast dilution in the blood, moderate dilution in the blood, slow dilution in the blood. Usually, if you want an average results, you go on the moderate one, okay? You have not to scroll down all the list, but if I put the mouse here and I cancel, okay, and I write GS, that stands for cesium, then I click on the arrow, and as you can see, it immediately appears cesium. So you have not to scroll all the list. You can write the first two letters of your radionuclide, and then you have all the isotope related to that radionuclide. I am talking very slow, and I do expect that you fail in doing something I am doing now, and you ask. Because if I finish the simulation, you are at this tab, we are losing our time, okay? So stop me anytime you need to stop me, please. Because in the setup you didn't change, okay, let's go again here. Go on setup, go back on setup. DCF library, you have to update it, FGR 13. I think you have FGR 11, right? FGR is the Federal Guidance Report of the United States of America. Why United States of America? Because the software is done in the United States of America. Okay? So now you have to put MERDIC International System and FGR 13, which is the most updated one. So let's go back. Model, we leave general explosion. let's go back on source term, change radionuclide, select nuclide from hotspot library. I do cancel the content of the library. I write GS. I click on the arrow, and I have all the isotope of cesium, okay? What kind of isotope do you expect I will select for the simulation? We already did the radiological nuclear module. Cesium 137, because it is one of the most common in case of nuclear bomb explosion or dirty bomb explosion. Do you remember the difference between a dirty bomb and a nuclear bomb? Please tell me the difference. Yes, all inside.
Generally not involved a nuclear explosion.
When there is an explosion of a dirty bomb, you cannot talk about a nuclear event. It's a radiological event. Nuclear bomb? Okay, he has done, buongiorno. He did the 50% of the reply, the other 50. What is a nuclear bomb? Okay. What kind of chain reaction? Both. Sure. Or both.
Yeah.
What is the difference of the name if you have only fission? No, it's easiest the question. How do you call the bomb if it is only fission? What is the name of the bomb if I have only fission? Atomic bomb. If it is only fusion or majority fusion? Or thermo? Okay. So do not confuse atomic bomb with thermonuclear bomb. Okay? Thermonuclear bomb is fusion, atomic bomb is fission. What is most powerful? Now you have not to remember the lecture, you have to remember the movie, Oppenheimer. Why? Not only for that, but okay, I take the answer as good. What is the maximum energy released by a thermonuclear bomb in experiment done on planet Earth? Tsar bomb, yes. Tsar bomb is a bomb owned by Russians. Okay. What is the maximum of energy released in an experiment and the maximum of energy that can be released by that bomb? 50 megaton. 50 million of ton. This is how they did use in 60s, but the bomb can be used up to 100 megaton, and 100 megaton is the maximum value of energy we can set in the nuclear explosion program that we will see by the end of the day. So you have a maximum of 100 megaton, because at the moment on planet Earth does not exist a bomb with the highest capability in terms of energy. So we will see how long is the contamination plan if such a kind of device is used. So you will understand why diplomacy goes over fighting among people, because nobody wants such a device dropped nowadays in some part of Earth. What country have the nuclear bomb? Let's see if you remember. Pakistan, India, at the moment, the only two that are not in war. Then Israel. Israel, how many? More or less. 100 declared. But they stopped to declare it in 2022. So we do not know at the moment if in the last 3 years they have done more. We have no idea because they stopped declaring it 3 years ago. Then China. How many? How many? More or less, yes. Russia, more or less. United States, similar, a little bit less than 6,000. Then UK, how many UK? No, 100. France, 300, more or less. Then how many? 100 declared. What was the progression of the disruption of nuclear bomb over the last 5 years? Increasing or decreasing? Who decreased? What are the nations that decreased? What are the nations that decreased the number of nuclear bombs in the last 5 years? Decreased? United States in the last 5 years. Then, more than anybody else in the world. Russia. Decrease. Who increased the most in the world? China. From 100 to 1,000. And then Israel, we have no idea because there are not data declared. Why nobody complain with China? That's a tricky question. In your opinion, it's the only state in the world who is increasing the atomic arsenal. No, because they are 2 million. If you go in the war, there are a lot of people, in my opinion. Just because there are a lot of people. And nobody complains. It's
Sorry,
just a
Andrea,
matter of...
what is
It's
the
just
question?
a matter for me of, physical strength. Why in Europe, basically, France speaks for everybody when we talk about protection? Because they are the only one with the nuclear bombs in the European Union. So whether you like or you do not like, when they say they are our nuclear umbrella, they are our nuclear umbrella. Nobody else has nuclear bomb. Now, question number 2. Is the property of the bomb similar to the geographical dislocation of the bomb? No. Does Italy has atomic bomb?
Yes.
Not only Ariano, more or less 80, all over the territory. So is Italy a nuclear target in case of atomic war?
Yes.
Yes. What are the other places in Europe where the NATO, basically USA atomic bomb are dislocated? Netherlands? Turkey?
Germany.
Germany? Yes. Netherlands, yes. So basically all Poland, basically all the nations that host atomic bomb are an atomic target. Okay. Then I do not want to go into the nuclear plant decision that we took in Italy to do not put nuclear plant in our country, but we buy the nuclear energy from France because I have to spend all the morning on that, and it is not the module. But when we do the simulation, and we will do the simulation also with the nuclear program, we have to start to simulate the explosion of bomb in the states that host or have nuclear bombs in order to understand what can be the situation in those states. Okay. So let's go for now with cesium 137. By the way, if you want there is this site which is nice. Let me nuclear bomb. There is this site is Federation of American Scientists, and you have basically the number of bombs that have been declared by the nations, and you can see also this is the situation. It is updated to 2025. This is the inventory in terms of retired, reserve non-deployed, deployed non-strategic, deployed strategic, and then the evolution of the nuclear bomb. As you can see, we had two peaks, one from USA with 30,000 and one from Russia with 40,000. Then Russia, UK, and USA, those were the three first states to sign the non-proliferation treaty back in the 60 or 70, I cannot remember. They start to decrease, and if you see, they stop to decrease the arsenal in a very important way, more or less around 2014. What happened in 2014? Russia entered inside Crimea. Is that a coincidence? Maybe yes, maybe no. That's geopolitics. I do some other stuff, but it's very curious that they basically stop a huge decrease of the arsenal, more or less, in this period of the history. Then another thing, and we go on. Deployed non-strategic, it means tactical bomb. Deployed strategic. We heard a lot of time by the media that's the maximum risk we can have, for instance, in Ukraine, or the maximum risk we can have, for instance, in a country which is fighting with Israel, okay? I am not talking about Palestine because it has no sense to drop in this moment a nuclear bomb in Palestine. There is no need, but the risk occurred, for instance, in Iran a few months ago. The maximum risk is use a tactical bomb. And the media, if you remember, and it is very important for a CBRN expert, the media talk about the use of a tactical bomb like a minimal event, like a small event, okay? So what's the energy of a tactical bomb? According to the International Atomic Agency, and I say according to the International Atomic Agency because almost all the countries we mention, almost, because Israel is not inside the agency, but almost all the countries I mentioned, Europe, USA, Russia, Ukraine, they are all inside the atomic agency. So the definition of a tactical bomb is the same for everybody. Less than 50 kilotons is a tactical bomb. Higher than 50 kilotons is a strategic bomb. Okay? So in terms of energy, it has no sense to make a difference between tactical and strategic. In terms of military use, yes, it has sense. But in terms of energy, it has not sense. Because if you think to Hiroshima or Nagasaki, in Hiroshima, we had the use of 15 kiloton, more or less, 15 kiloton bomb. And in Nagasaki, 18, 19 kiloton bomb. So it is 3 times less the maximum value in which a tactical bomb, tactical atomic bomb, is considered by the Atomic Agency. What does it mean? In Hiroshima and Nagasaki, USA has used a tactical bomb. Now, if we think in terms of injuries and casualties, we have more than 100,000 direct victims by the explosion during this event. So it means that a tactic bomb in an area of the world with a lot of population can provoke hundreds of thousands of casualties just with the explosion. So I am honestly disgusted by the media when they say the maximum risk we can have in a war scenario nowadays doesn't matter if it is Eastern Europe, Middle East, Pakistan, India, Italy, and whatever it is. I am disgusted that they say that a tactical bomb is something little, something small. Okay, so we have to keep in mind that we have to fight also with the miscommunication and wrong communication. Okay, so cesium 137. Let's choose it, and we go with the moderate. So cesium 137 moderate. This is once you click OK, you have the possibility to enter inside this table, and you have three tables. You have the inhalation. Yes, is a fast, moderate, and slow. Fast dilution in blood, moderate speed of dilution in blood, and slow dilution in blood. So once you pick the isotope, you have those tables. Those tables are, the first one is the inhalation dose conversion factor. Then you have the submersion, air submersion dose conversion factor, and the ground shine dose conversion factors. And those are the ones reported per each isotope that you find on the Federal Guidance Report 13 of USA. What you can do, I talk for Italy, but it is the same for every country. You can take all the CRP guidelines of the Atomic Agency, or you take the legislation of your own country. In Italy, we have a law that is called 101/2020, 101 del 2020. You can read the value of the law that is in your country, and you can change the value inside this table according to the one that you have on the law. For this simulation, we will leave the one of the Federal Guidance Report, but you can change every value of every conversion factor in the table. That's basically, as you can see, affect a different part of the body or a different organ of the body. Okay? Once everything is set, you click on Return, and you find under the voice radionuclide cesium 137 moderate. Okay? Before going on the other value, we take a 10 minutes break. That's the lowest speed I can go. But if you have doubts, raise the hand, stop me, and ask.
Io pensai a It's not very
Abbiamo i fogli presenti, abbiamo giornata, abbiamo i riscontri al corretto. Questo è interessante. No, vado a fare la macchinetta. Ne ho presi già due, vi ringrazio. No, andate con la bar, tranquillo. E io, guarda. For Mac it is impossible. You have to do virtual machine. You have to put Windows inside.
Allora, vale queste cose. No, non può essere. Allora, giusto. You must have given picture. Very good. والله يعني والله سيدنا الله بس انا في بعض اتوقع لا لا اسكتي والله يا نعم عاد بعض تسوي ما في شيء والله يعني بحب واحد ثاني اسبوعين ايوه مقدمين لكن شوف اللي كنت سويت مثلا مقدمين كانوا 50 طلعوا شمس مرات يوميا ايه حتى الجو الحين شويه بالليل حصل الجو الصبح الجو الصبح لا يعني ان شاء الله
إذا بتصير الحمام ترى قريب أنا صار سكت دربات ممكن شو لا تسوي؟ يعني لا تم إنك تصل ليس
Sorry, I think my phone is in my pocket.
Okay. Like. That's great. So this is what we supposed to do.
It is a most license, chemical, biological. We are still moving towards the strength. How to do the next strength? Oh, yeah. Let me call you. Bro, okay. I'm trying. I just. All of us that started. So you know 22 inch. I did those start on well, I think it was good. It's fully. The timing it's consumed time. But it's not, but it's extremely. Yeah, what is. It's great, it's 500. Is everyone different? Okay. You know how many licenses? Yeah. You just get some over and it'll be. Lost the base. Yeah. It's. Well, my confidence or concerning 31st of August next year. My vacation starts February. Studying here. Studying money. Just still. So. I also apply for the civil rights base course. After you've done that, I was sure I'm going to you've done that, then you can be sent by civil process and then as like semi-military. One of the specific questions about so they have some corporations. Yeah. But for example, it's funny, I applied. I had spoken to people. It's not, they don't see the military side. And the main obstacle for to be maybe not meet everyone. Yeah, it's my what matters. It's possible that you know my background. So it's okay. I'm doing it. So there's some lots of jobs in the prayer, like a star, like or lots of lots of jobs. Lots of jobs. If you want, they're like all the police. I'm like, what the? I know. I was, another 2 months ago. I was a bit fan of some of the guys. So, yeah, so might be, because we it's like American distribution partners. It considered to also was no, yeah. So yeah, it's not like you said, part of it, I think it's very something there, My life is something that I think, yeah, but they're all like those short. Those short versions like 2 to 3 months. Yeah, the one you do lot of them. Oh, that's not bad. I know lots of one. Hey, Mike, I'm John. Can you help me with that? It's, do you know
Yes, I tell you the numbers.
let's see. It's wrong. Fine, without providing correctly.
Yes.
We can. Why?
No, American.
Very simple. So you know what to see?
Yes.
Check. I think I have it. A little bit more. So now it's there. Yeah.
Okay. At 0.
Everybody. Okay. Oh, thank you. My God, too. Ninja Turtles. You're really good at it. About I think you saw something. Let's say based on it. Yeah. No, what happens to the slide? One thing I think that she not usually they end just some
It is so terrible, the election. So Alba will come in Dubai 2 times. Yes. First, 4 of October, that weekend and the weekend later. She has to travel in Uzbekistan and in the middle of the 2 weekends. She will have a weekend there because the brother of Alba lives there. Then she goes in Uzbekistan, and then the other weekend she will be there. And then for our 10 years of wedding, I buy her 5 days in Dubai because I feel safe when she goes there. I will stay with the baby. She has a resort in Dubai on the Palm. Okay. Spa. She has 5 days of spa. Yes. Spa and sleeping. That's it. I would like to say ready for another 10, but it is not true. I mean, I have to do it, but yes, 10 years of wedding this year and 15 together in total. My age, guess. I am old.
Really done.
I'm old. Ah, okay, a little bit less, but just a little bit. Not so young. When I was 30, I was younger, you know. My condolence. When I will arrive at 17, I will lose the 3 years that I have here. Colomba non stai registrando, no? Asking Colomba if she is recording or not.
Yes, I'm recording.
Brava, complimenti.
Anch'io.
Guess we got all the meeting. It does a bit. I think they are still with it.
Oh, no. I think that's a lot, but I haven't.
Come direttivo?
No, non direttivo, per
gli argomenti di tesi posso fare delle proposte.
Noi manderemo delle proposte dopo questo modulo e voi potete fare delle proposte.
Per esempio, io ho lavorato per anni nella demilitarizzazione, civili convenzionali.
No, ci sono state già 3-4 tesi su questo tema. Potete fare delle proposte che vi interessano a voi.
Ok, quindi ti faccio una proposta di
È come si dice push and pull, cioè ricevete delle proposte ma ne potete fare anche.
ok. Quindi, sì.
Poi chiariremo tutto, comunque quando le fate voi dovete proporre un titolo che poi si può modificare, qualche richiesta di iscrizione, noi vi assegniamo un relatore, poi iniziate a lavorare con il relatore. Molto, molto tranquillamente.
Sì. No, perché in qualcosa non già fatto.
Okay, let's move on. We have to continue to add value inside the source term tab. The second value we have to add here is the material at risk. When you click on the space to add the value, immediately Hotspot open for you a help window that explain you what is the value you are going to add inside that box. You will find a larger and more detailed explanation on the user guide, but if you need to read something during the simulation, it is an helpful tool. So if we read material at risk is the total activity of the nuclide involved in the release scenario. And being an activity and having added the international system, we have the Becquerel. What is a Becquerel? Mo stavo a dire una parola. I was going to say a bad word. There is written the activity. It is clear that is the activity. It is the activity, but it is on the window that is the activity. So what is a Becquerel? Is a unit of measure of the activity, but what Becquerel represent? From a physics point of view, 1 Becquerel, what does it mean? Number of decay per second. So highest is the activity, larger is the number of radiation that comes from that source over the time. Okay? Did you study the radiological nuclear module or you left all the work to ChatGPT? That you are strongly using. This is the thing you mostly learn to use during the master course is ChatGPT. I can say exactly where and when you use it. It's very easy to find when you use it, but at the end of the game, you need to learn also this stuff. Okay? I am telling that for you. Because if you do not learn this basic stuff, not me, but you are losing time. Okay? So Becquerel is the number of decay per second. Highest is the activity, highest is the number of radiation that comes from a source over the time. Here we have a value of 3.7 over 10 becquerel, okay? So what is 3.7 plus 10, exponent 10? It's 37 billion. 3.7 exponent 10 is like 37 exponent 9. Exponent 9 is a billion, okay? So it's 37 billion becquerel. Yes. I change to 3.7 becquerel. If you have a different unit of measure, you have becquerel. It is written BQ. Do you have BQ? Okay. Go on setup and change radiological units, international system. No, you have to do at the beginning. That's it. You redo it. Welcome in the open source software world. If you want a better software, pay. Okay. If you want it for free, you have to change 50 times if you need it. Okay. I know. You struggle with that, but think to MBC analysis. Okay. MBC analysis, the top software for nuclear biological chemical dispersion, recognized by NATO. It means that the output is in ATP45 format. That is the one recognized by NATO. One license for one computer, 50,000 euro. Hotspot, same results, same Gaussian model, 0 euro. Okay. So I think you can change sometime the button. That's my humble suggestion. But you can buy MBC analysis. I don't care. It's your money, not mine. So let's move on. By the way, you have also MBC analysis, Dario, back at the school. You have more than one license, if I am not wrong. And the first level master course will see the MBC analysis at the MBC School of Rieti next year in the training Italian week. Okay. Then let's move to the closest value, damage ratio. Click on it, enter the fraction of material at risk actually impacted in the release scenario. What does it mean? If I say that my material at risk is 37 billion becquerel, and here I put 0.8, it means that only the 80% of the material at risk impact on the scenario. If I leave 1, is 100%. So all the 37 billion becquerel goes in the scenario. So if you want the worst case scenario, you have to leave 1 because you are multiplying what goes on the scenario per the material at risk. So if you multiply per 1, you have all the value inside. Okay. Then you have leak path factor, which is the fraction of the material at risk that passes through some confinement or filtration mechanism. It is useful if you want to do some consideration inside the building. So what happens inside the building? When you have an explosion, you can have the window broken, but you can say that a part of the wall is shielding some of the material that is entering inside the building. If you leave 1 here, it means that all the material that is outside, you have actually indoors. So again, leave 1. So leave 1. So even the filtration and confinement does not help the protection of the people. Everything impacts on the scenario. This one, like the previous one, is 100%. All the material at risk goes in the scene, and all the material at risk passes through some confinement or filtration mechanism. You are not shielding. This is the worst case scenario. Is general. Even the mask. It is like the mask, it is not working. You keep everything, okay? Then deposition velocity is the new respirable release deposition velocity, and it is measured in centimeter per second. It has been evaluated in the Federal Guidance Report 13 that the respirable release deposition velocity, an average value, is 0.3 centimeter per second. So we leave, even in this case, the default value. But if you want to simulate some person that is scared, that breathe very heavily because he's scared, you can increase this value, okay? Then the explosive, the only thing you cannot report in the international system is the explosive unit of measure. We didn't change the up to 40 centimeter per second. If you go here on deposition velocity, you can, deposition velocity, look at the upper part of the suggestion tab, 0 to 40 centimeter per second. Okay? So you can increase up to that value. Then what do we have? 5 exponent 1. It means that the value inside is high explosive is 5. LB is pound, basically. Okay? So we have to calculate how many kilos are in pounds. So if we want to simulate a 50 kilo explosive situation, we have to put 100 pounds, more or less. We want to simulate here a 25 kilo explosive situation, we will put 50 pounds. So we have 5, we put 50 here, and we go on, okay. 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 It doesn't take 50, so you have to put 5 I a exponent 2. You have to write something like that. Ovviamente non c'è il gesso. Gesso, non c'è il gesso. You have to write 5 e 2. 5 exponent 2, which is 50. Okay. You click on OK and you have the value here. Then there is another box. You find airborne fraction. Enter the fraction of the impacted material at risk that is released to the atmosphere. We leave 1 as default value. Enter the fraction of the airborne material that is respirable, less than 10 micrometer aerodynamic diameter, assuming an aerodynamic diameter, an average one, of 1 micrometer. And we go with 2. Those are the default value. Then we have to move, so we leave basically rather than the quantity of explosive and the radionuclide, we leave all the default value for the first simulation. Let's go on meteorology. With the meteorology, you can do three things. Number one, you go on internet and you look at the meteo condition of the place in which you want to simulate the explosion. And this is what we will do today. Number two, let's say you are using this software without internet on a cell phone, or you're using it on a computer, and you have not the chance to measure the meteorological condition with instruments on field, and you have not the chance to look at the internet. So what you can do, you can look at the nature that is surrounding you, clicking on display wind chart. If you click on display wind chart, there is a table that helps you to add the value of the velocity of wind, looking at the nature surrounding you or looking at the environment surrounding you. For instance, if you see smoke rises vertically, the value of the velocity of the wind speed you can add is less than 0.5 meter per second. If the smoke drifts downward, it is called light air, and you can add a value between 0.5 and 1. If the wind felt on the face and the leaves rustle on the trees, you can call it light breeze, and you can add a value from 1 to 3 meters per second. If you are in the middle of a storm or an hurricane, it is a useless use hotspot. You have other kind of problems, so you can avoid it. By the way, you find the definition in this case, but if you are in the middle of an hurricane and you're doing simulation with hotspot, you are an unhappy person, because in that moment you have to think to save yourself, okay? By the way. So you can look at the environment surrounding you. You can look on internet, or of course, you can plug inside the computer a meteo station, and hotspot is able to take the temperature and the wind data from the meteo station you plug in on the computer. So you can couple hotspot with instrumentation that you will connect with the computer. You look at the internet, you look at the environment. You have three ways to add the velocity. So first of all, we will go with the internet. We will give a look to internet. In order to find the right meteo condition, the first thing we have to choose where we want to generate this explosive event. And as I told you, I want to do it in the village of my mother and father, which is called Sette Frati, 7 brothers. So we will go to let the explosion happen in the municipal building of Sette Frati. So we go with Google, Sette Frati, meteo condition, and we open, I don't know, one or the other is the same. We open a meteo website, and we see, here we have the value. We see that the wind, sorry, okay, we see that the wind in Sette Frati in this moment is, let's say, 4 to 5 kilometers per hour. Then we have to transform kilometer per hour in meter per second. How many meters per second is 5 kilometers per hour? This is the calculation, especially first responder has to do like that on the field. So take a calculator on the cell phone, paper and pen, and make the calculation, or chat GPT and ask if you want to brain drastically freeze it forever. How many meters per second is 5 kilometers per hour? Again, please. 2.3, 3.6. So here we open the wind speed and consider that the value that you read on internet is a value that the instrumentation takes usually at a height that is 2-3 meters from the ground level. Here, the wind speed that you have to put is the wind speed at 10 meters from the ground level. So you should take a little bit higher. If you have 3.6, let's do 5. Okay. Okay. Once you put 5 here, it automatically selects the stability class. Ok. Forse wind direction deve cambiare. What is, for instance, stability class C? Is slightly unstable. What are the stability classes? Stability classes, let's see it. Are the Pascal stability classes, and those are the classes. When you have a surface wind speed less than 2 meters per second, you have in daytime A or A to B classes. So it depends basically if we are calculating the simulation in daytime or nighttime, and it depends also from the wind speed direction. And those are the stability class, are the class that consider the capability of the atmosphere to disperse certain substances. And we will have it for the radiological dispersion, we will have it for the chemical dispersion. Okay? You can, if you have no idea about the stability class, it is okay even if you look at the solar information, sun high in the sky, sun low in the sky or cloudy, night. So if you have not the way or time to evaluate the Pascal classes, you just give a look outside, and if it is sun in the sky, you put the first box, sun low in the sky or cloudy, you put the second one, night, you put the third one. Oh, yes. Use it. I have no idea. I have to see your computer. I have to look at your computer. I will come, I will take a break after receptor tabs and I will come to give a look to it. Or the glasses, or the solar information, or you leave the selection the software makes for you, like in this case. Okay? So you can force your stability class. You can leave the stability class the software choose for you, or you have not the chance to evaluate the proper stability class, so you enter the solar information. That's it. In all the 3 cases, the software works. Then you have to put the wind direction. Wind direction, if you click on this box, if you put a number from 0 to 90 degrees, you have 0 is north, 90 is east, from 0 to 90 is northeast, okay? 90 is east, 180 is south, and 270 is west. So in this case, if I put something closest to north, so closest to 0, I am adding here 14, which is between 0 and 90, but is closest to 0. It tells me the wind is north-northeast because I am closest to 0. But again, I go on internet. What is the direction of the wind? Direction of the wind is south. So if I want wind on south, I write 180. I click on OK, and it changes wind from south. Okay. What does it change the wind? The direction of the plume on Google Earth. If you change the direction of the wind, you have different position, different direction of the plume. And we complete the meteorology part. Receptors. First of all, what is the receptor high that you find on the upper part of this tab? It is, by default, the average height of the part mouth, nose, from the ground. So it is this part of the body. In the past, it was 165 meters from the ground. Now the worldwide population increased a little bit high, so it is a proper value at 170, 175, because the average worldwide population is a little bit higher than the 90s, okay? But if you want to live 1 meter 65, it's fine. I go usually for 1.7. Okay.
But in meteorology, why we put 5 wind speed?
Because we saw that it was 5 kilometers per hour at 2 meters from the ground. That is 3.6 meter per second, but we have to put the value at 10 meters from the ground. So we put it a little bit higher. That's it. There is a table. You can calculate it. Yes. I have just done a rough estimation, but you can evaluate it. Yes. Then once you put the receptor high, so the high from the ground of mouth and nose, more or less this part, you have for the table output, so this is not for the graphical part, hotspot as output will give you 2 outputs, graphical one and the technical report. For the technical report, he will estimate the radiation contamination at each of the distance you put in this table from the point in which you have the event of release. So in this case, we have the explosion that is our ground zero. Then in kilometers at 3 meters, you have the first calculation that the software does. Then you have 100 meter, 200 meter, 300 meter, which is 0.1 kilometer, 0.2 kilometer, 0.3, okay? As you can see, you can change this value. Where do you want from the ground zero the calculation? Here the default is for the first kilometer, you have every 100 meter. Then it increases from 1 to 2 kilometers, from 2 to 4, 4 to 6, 6 to 8, 8 to 10, and then you can stop. I mean, you can add up to 100 kilometers, but the user guide of hotspot specifically say that above the 10 kilometers, the overestimation is the mathematics, let's say the software use, is too bad that you cannot consider it, okay? By the way, you can have a graphical idea of the plume. For instance, when we will go with the nuclear special purpose, we will have a plume that arrives also to 30, 40, 50 kilometers, but do not let's say, do not consider very good the value that you find on the technical report for distances higher than 10 kilometers from the ground zero. The Gaussian model works quite well from 0 to 10, more or less. Okay. By the way, it will make an estimation also at 20, 40, 60, and 80 kilometers from the ground zero. You can change all of these receptors. So you can create your own point in which the software will do the calculation from the ground zero, and you will find these results on the technical report at the end of the simulation. And then we do arrive again on setup. So we already did something on setup. Radiological units, we put international system. Distance unit, we put metric. And we select the Federal Guidance Report 13. Let's see the other value I can select here. I can select the standard rural terrain or a city metropolitan area. And I can decide to add the roughness of the surface. It is the most conservative option. Why? If you have an explosion in a city area, you have the other building that contain a little bit explosion. If you do an explosion on a rural terrain, the effect of the explosion is not contained by the building. It is clear that in terms of impact on the human lives, the rural is less dangerous than the city one. But in terms of capability to extend the damage of the explosion, the rural is worse than the city metropolitan one. Then sample time. Here you have 10 minutes. You can modify this value from 0.01 minutes to 2000 minutes. What is this 10 minutes? Is basically the time that it is used in the Gaussian concentration distribution equation to make the calculation. And it is a standard value. But again, if you want to go into the mathematics, you can change it. I am not going into the mathematics because this is something I do for the course of engineering. It is not part of the CBRN course, but if you are a nerd and you like mathematics, you can study on the user guide how does this number impact on the simulation. Here we want a plume of dispersion or contamination. We want to georeferentiate it on QGIS, and we want to see how many people lives under the plume, how many hospitals you have under the plume, okay? How many first responder or advisor you have under the plume, how many medical personnel you have under the plume, and so on. So we want to arrive to do a layer georeferentiation to handle the emergencies. Let's see what other we have to put it. Wind input height, we leave the default value that is 10 meters because we do refer to the value of the velocity of wind of 10 meters. Source geometry, we leave simple. We do not enable the inversion. This is the atmospheric inversion. When do you have atmospheric inversion? In the beginning of the day. So when the sun is rising and at the end of the day, you have the atmospheric inversion. So in this case, if you are calculating, if you are doing the simulation, when we pass from day to night and from night to day, you have to enable the layer. In any other case, like now, 11 a.m., you have not to enable the layer. Then non-respirable deposition velocity, we leave the maximum value, which is 40 centimeters per second. And it is a very nice, okay, wet deposition, enable rain out. Is it raining in Settefradi now? No, that was we saw in the meteo that we have sun high in the sky. So we have not to enable rain out. We are not in wet condition, which is the worst case scenario, because again, when you have the rain, an explosion reduce the impact of the dispersion of the material over the air. Then hold up time. What is hold up time? The default is 0. It means that the material is immediately released to the atmosphere. It means that all the material released by the explosion is released in the atmosphere in that precise instant. If we put 3 minutes, 4 minutes, 10 minutes, it means that after the explosion, the software calculates that in order to release all the material we put as boundary condition, the scenario takes 5 minutes, 6 minutes, 7 minutes. It is clear that if you want the worst case scenario, you have to leave 0. Everything is released immediately. Then include the ground shine, include resuspension. So let the ground give back to you the material when the material arrives on the ground. Let's consider the ground giving back something to you, which is again a worse situation, because when the material arrives on the ground, you have something that is resuspended from the ground. And once you have set all these in the setup, the breathing rate for the Federal Guidance Report 13 is 4.17 E-4 cubic meter per second. This is the breathing rate that on the average is being calculated for the human being. If you look at the value for the FGR11, do not click FGR11, but is lowest. So it means that between the FGR11 and FGR13, that are 2 federal guidance reports, the average human being has been considered breathe heavily rather than the past. Why? Because we get fatter during the year, so we breathe more heavily. Then we have to add the limit of our simulation, but for the limits, we take another 10 minutes break, okay? Piano piano, non ci vedi una mazza. Tirare il cervello.
Sono 2 quelli che fai.
Era quindi del zero tipo.
Passi d'accordo, quindi
Sì, io non ho tempo di darmi queste lezioni, ma facciamo anche
Se non ci vediamo un po' di tempo. Si lancia il quando c'è un prima di questo beh sì, in qualche abbiamo fatto un secondo, ma non è che lo sa, però sì, qua ci sta 20 km/h. Una 20 km/h. Io non so se lo sì, 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 poi ci io qua però ha detto, anche normalmente cioè se tu sei a 10 km/h, di 10 km/h, moltiplichi per 3, 6 e poi la progressione da no, ha chiesto come si fa il salsare effettivamente la progressione. Perché va bene, però attenzione che non dobbiamo prendere, c'è il software, vuole la velocità a 10 km/h. Quindi se si vuole la velocità a 10 km/h, usiamo 5 per le conversioni di metro 6, così teniamo conto di verso un po' alto se tu hai di mettere 10 km/h, tu devi mettere fai per 5, 40 km/h. Perché non era il terra. Sì.
Posso approfittare per una domanda?
Yeah.
Lupoli da casa, da casa da videoconferenza.
Poi, ciao.
Buongiorno. E solo un chiarimento, hold up time.
Sì.
Il tempo che inseriamo vuol dire, mettiamo 5 minuti, vuol dire che al quinto minuto viene rilasciato il tutto?
Al quinto
o vuol
minuto
dire...
c'hai tu. Ci metti 5 minuti per rilasciare tutto.
Quindi da 0 a 5 comunque viene rilasciato il materiale,
Sì.
questa è la domanda. Ok, va
Se
bene.
tu invece metti 0 è rilasciato tutto subito.
Sì, sì, non capivo se era solo un delay o un progressivo di
No,
rilascio.
è un progressivo, anche se voglio capire come lo calcola il progressivo vedendo le
Questa era la
equazioni,
seconda domanda.
però da user guide dice che è un progressivo, poi effettivamente vedendo la matematica che usa, com'è che considera questo progressivo non mi è molto chiaro ancora.
Sì, anche a me. Va bene, grazie.
Nulla. Ok, let's move on. We have to set now the limits for the design of the plume of dispersion. And we can obtain two plume to the sign of dispersion. The total effective dose, so the dose, and the deposition on the ground that is measured in activity over surface, kilobecquerel over square meter, okay? The dose is expressed in sievert. What does a sievert represent? Say better. No, you have to say it better. You have to be precise on that. What is a sievert? The amount of? Guys, you are 60 person. And we have done 1 week on that. What is the dose? 1 sievert, what does it represent? Energy absorbed over weight of material. Joule, that is energy over kilograms. So is the energy released over kilogram of body. Okay? So we have limits given by Italian or international legislation. Do you remember the limits of the dose? Or as worker, you know the limit of the dose? 1 millisievert per year is for the population. 20 millisievert per year is for the people that work with radioactive sources. 100 millisievert per year is for the people that work in the emergency, for the CBRN first responder. It doesn't mean that if you take more than 100 millisievert per year, you will develop some disease. It is just a threshold of probability to develop something. You can take one and develop, which is one is the one given by the simply gamma radiation coming from the sun on the earth. So you can have a regular exposition without particular irradiation and you can develop cancer. You can go under 100 millisievert per year and develop zero health issues. From a legal point of view, what does these doses represent? If you are working with a source and your limit is 20 millisievert per year, I don't know, you are a person working inside the nuclear medicine department of an hospital. Your limit is not 1 millisievert per year, like the limit of the population, which, just to be clear, we take more than 1 millisievert per year. In Italy, we take usually 2-3 millisievert per year. By the way, If you take more than 20, it doesn't mean that you will develop a disease. It means that they have to take you out from the working place where the radiation is present, and you have to spend the rest of the year inside the office. That's it. If you are a person working in the emergency, you do one operation on field, and in this operation you take more than 100 millisievert, for the rest of the year, you cannot go on field. You have to work inside the office, okay? So 120, 100 are the limits by the law. Here we put lowest value to have the map. What does it mean? It means that every time we have a dose that is higher of 1 to -8 sievert, we are in the inner area. When we have a dose that is higher than 1 to -9, but lower than 1 to -8, we are in the middle area. When we have a dose that is higher than 1 to -10, but lower, sorry, than 1 to -10, but higher than 1 to -9, we are in the outer area. Same concept for the deposition value. 37, 3.7, 0.37 kilobecquerel per square meter. Now we click on color option. And on color option, we want to change the color of the zone. In the inner zone, we put a red color. In the middle zone, an orange color. In the outer zone, a yellow one. Because it is easiest to understand, because from a visual point of view, for us, red is the most danger, orange is average danger, yellow is lower danger, then there is green that is no danger, okay? So the color that they use on the software, red, green, and blue, are not easy to understand when you go on the map. So it is better to change it in red, orange, and yellow. Then you have to put line width 3. You have to put fill the color. Why do you fill the color? So all the inner zone is colored even inside with the red color when you put it on the map, and put a transparency of 50%. So you can see the houses when you will put the map on Google Earth. If you do not put transparency at all, you will have a red colored area that covers the image of the houses. With 50%, you see the red, but you see the houses below. In order to change the color, you click on inner and you put the color that you want. As I suggest you, for inner go red, for middle go orange, for outer go yellow. Line white 3, fill, box the fill option, and then transparency 50% for all the cases. Once you did it, you close this window. Okay. Now we set all the simulation. See? Try to click on it. Does it work? I have no idea because I click on it and I can change it. Are you trying to click with the left button? The value, you have to start from the lowest and then you have to add the other one. You have not to start from the highest, you have to start from the lowest, otherwise you cannot change it. The highest value of the contour cannot be lower than the lowest value of the contour. It's illogical. This is why you cannot change it, okay? Il valore più alto della parte esterna non può essere minore di quello maggiore della parte interna, ok? Non è logico, devono avere una logica. Yes. Red, orange, yellow. Bring the computer here. Clementina, bring the computer here. Vieni. Oh. Oh. No. No, fare così. Che cazzo vuoi? No, forse vuoi. No, piccola 0-0, spaventa, questo non ti piace. Ah, virgola 0-0.
Grazie.
Okay, the problem that she has, and we try just changing. If you want to change the value, you have to write 1, comma, and other two numbers. 1,00 E minus 09. We try to write with her 1 E minus 09, it doesn't work. He wants the comma and he wants the other two digits. Why it is so tricky? Because you have to do tests, because it's free of charge. But if you write to the Livermore laboratory, they give you paying a version that is not so tricky, okay? If you want to do it for free, you have to suffer a little bit. Now we go on output. The first thing that you see on the upper part on the left side is text files. Text files, you have two options, plumb center line or compass. We will see later what these two options are. For now, you leave a plumb center line. Then what do you want on the report, on the text file? I want all TED component. I want all organ data. And I want to append quality control data to the simulation as well. If you put not all organ data, but only the organ exceeding 0.5 sievert, you will have on the table only the organ that exceeds 0.5 sievert. If you want all the contamination for all the organ, you go for all organ data. At this point, you click on table output, and it generates in 2 seconds the simulation. So this is the simulation time. All the work that we have done till now is to set the simulation data. Once you have confidence with the software, you can set the simulation data in 5 minutes, okay? But the important thing of this software is that the simulation time has been 2 seconds. All the calculations are done by the software once you click table output. So it overestimates the data, but it gives you results in seconds. In the first part of the file, till ground roughness correction factor, you have all the boundary conditions. So in this first part, before all these tables start on the TXT, you have a summary of all the data. We put a summary as boundary condition in the simulation, starting from the version of hotspot. If you go at the beginning of the file, hotspot version 3.1.2, model general explosion, when we did the simulation, September 15, 2025, 11:21, 54 seconds. So you have here the moment in which he has done the simulation. The simulation is not setting the data, is the calculation time between the request of the user and the output of the results. So we are talking about seconds. Here you have all the data that we put, and then per each distance we select previously, we have a table of the contamination. Here the distance, as you can see, is 0.03 kilometers, which is 30 meters. So you have the value in sievert of contamination per each organ, the arrival time, how long does it take from the explosion, this contamination, to arrive to 30 meters, less than 1 minute. How long does it take to arrive to 100 meters? Less than 1 minute. How long does it take to arrive to 200 minutes? Less than 1 minute. So you can see how long does it take to arrive at a certain distance. What is the ground concentration? What is the dose that you take, and the doses per organ, according to all the data we set on it. So what you can do with this file, you can save it on the desk, for instance, and if you have to prepare a report for an advisor, for a decision makers, for your own working purpose, you can copy and paste a part of the TXT or all the TXT, bearing in mind one thing. Even if you use this data for a publication, for a scientific publication, for a paper, these are original data produced by you. So if you use the data of a simulation for a paper, you are producing original data. If you put this data inside the report for work, it is not plagiarism, because you have produced with a free license code this data by your own, okay? So you are not copying, you are producing data, which is different. So here you have all the results of the information, of the simulation, sorry, at the different distances. And in the end, what do you have here are all the variables used in Hotspot for the calculation. So at the end, you have a list of variables that Hotspot uses for the calculation. And at the very bottom, there is a quality control data. So with table output, we have the text part. But as I told you before, we can add to the text part also graphical one. And we have 3 types of graphics we can take. One graphic that is done on a coordinate system, that is contour plots. So let's go with the total effective dose plot. If you click on it, you immediately have the value of the plume, of the simulation, in which in the red area, all the values are higher than the value that we put as inner limit. We put as inner limit, if you remember, 1 to -8 sievert. So everything that is inside this red area is higher than 1 to -8 sievert. Then we have the orange area. Everything that is in the orange area is higher than 1 to -9 and lower than 1 to -8. And then in the yellow area, everything is higher than 1 to -10 and lower than 1 to -9. Okay? So these are areas that are created according to the data that we put in the setup. If we increase this value, the plume will become more little. Okay? Here the plume arrives over 200 kilometers. If we increase the value, we will have a little plume in terms of distance from the ground zero. And this point here is the ground zero, the point in which we put the explosion, okay? If we go with the compass visualization, it simply reports the same graph in a compass way. It is the exact same graph. But here you can see that the plume arrives almost to 300 kilometers. And remember that you can basically do both. Then we want to see what is the behavior of the decreasing of the dose and of the ground deposition over the distance. In order to do that, we go to plumb centerline plots. If we click on plumb centerline plots, here you can see this decrease over the space. It is a logarithmic graph at 10 meters from the ground zero, 0.1 kilometers. So 10 meters from the ground zero, you have the highest value of the doses, and then it decreases with the distance from the ground zero. So you have something like 1 to minus 10 sievert at around 100 kilometers from the ground zero. And it is done with the Pascal class C. If you want to see the effect of the meteo condition, if you go on option, you click on all stability classes, and it makes the graph with the different stability classes. It gives you an information on how the stability classes influence the behavior of the decreasing of the doses over the space for the same event. Here we are not changing the quantity of explosive or the radionuclide or the high of the wind. We are just changing the stability classes of the atmosphere, and look how huge is the impact of stability classes over the decrease of a concentration in terms of space distance from ground zero. It does the same. It does the calculation with the closest stability classes to the parameters that you select, and then if you click on the bottom, it gives you the other 5 options. Then ground deposition, you can do the same. Those are kilobecquerel over square meter, and it is 10 meters from ground zero, and this point is 100 kilometers from ground zero. Okay. Now there is the funny part. So we see the text part, contour plots, decrease of dose and ground deposition over space. Now what we want to do, we want to georeferentiate the data. In order to georeferentiate the data, we have to say where it is the ground zero. So we have to put latitude and longitude of the ground zero. In order to select the position of the ground zero, on the bottom part, left side of the output tab, we have to click on default source location, and then we have to go on set location. Once we go on set location, you have latitude and longitude selection, and we have to add the proper data of latitude and longitude. So we have to set our ground zero. This is the point in which the explosion will happen. We say that we want to go on Setefragi. So what do I do now? I open Google Earth. I already told you in the messages to install Google Earth. I ask you to install it because the online version is not very good to put the data from the simulation in. And here I already put something gold. Yes, with a cohort with a court from Saudi, we drop bombs on Sana on Yemen. It was very funny. I drop bomb on Paris and they drop bomb on Sana. And in the end, just for the par condition, we drop bombs on Rome and Riyadh. But just at the end of the day, because we were recording. So, joking apart, guys, let's search for Sette Frati. Sette Frati, Frosinone. Cerca. Ok. And here is Sette Frati. So if you click on Sette Frati, here on the bottom part on the right, Google Earth give you latitude and longitude. Look how this latitude and longitude change. If I move a little bit the mouse, this number changes. You have to look on your own computer. If you try to see the number on my computer, rather you are Superman or you have a very good view, okay? So what are the numbers for Sette Frati? Can somebody write the number with the pen and paper? So we have 41 degree, 40 minutes, 11 seconds, 41 degree, 40 minutes, 11:75 north, and then we have 13:51:02 36 east. Did you write it? Okay, take a pen and a piece of paper. So 41, 40, 11, 75 north, 13:51:02 36 east. Salute. Okay, did you write it? Can you write this number with a pen and a paper? Okay, 41, 40, 11, 75 north. And then 13:51:02 36 east. Okay, did you write the value with a pen and paper? Thank you. L'ho ripetuto 4 volte, però. 41, 40, 09, no, mi sono spostato. Buoni tutti. Give me the number I give you before. So latitude 40, 41, 40, 11, 75 north, and then 13, then 51, 31. So 13, 51, 31, 31, no? 13, 51, 31. 13, 51, then 02. Okay, and then the last one, the fraction. 36 east or west? East. Okay. And we set the location. Return. At this point, if I download total effective dose file, okay, I save the total effective dose file on the desktop, and I call it test 1 Sette Frati, okay, and I save it. It appears, okay, it appears here. So I open Google Earth. set the location, then go on Google KLM output and click on total effective dose file. Then save the value, call it as you want, I don't know, test 1 7 frati, save it on the desk, okay? Once you save it on the desk, with the Google Earth open, just take the file, click the left button, and with the left button clicked, drag the file on Google Earth, you have the map. Look with 250 kilogram of explosive. If I set low doses, how large is the contamination area? It goes more than 200 kilometers far away from Italy, from my village. By the way, my village is destroyed for sure, such as some other villages. Yes. I eat also your house, right? No. Okay. Is everybody done the plume on Google Earth?
Yes.
I have some problem with the hotspot location. Can I ask?
If the wind change, if you now you leave the same, we leave the same results. Wind is here is 180, okay? Let's go with 94. So let's change only the wind direction. Go on output, total effective dose file, desktop, then let's call it simulation 2, okay? Let's drag simulation 2. You have the same point, the same simulation, but with two different wind direction. So when you do the simulation and you want a nice graphical interface, what do? You do north, south, east, west, and you design a circle. So you can say, okay, doesn't matter the wind direction, changing the wind direction, but this is the overall circle that it is hidden by a contamination in this scenario. So changing only the wind direction, you have the same plume with a different wind direction. And there is nothing you have to do rather than go change the number, say with another name, drag inside Google Earth. At this point, you have not to redo again everything. You have just to change one value. You can improve, you can increase or decrease the quantity of explosive. You can change the limit of the doses. You are free to change even one variable and then redo the simulation and then compare the different scenario. Okay?
Scenario for interfering with aerial navigation.
Police.
No, it's made.
It's made already?
By us.
Okay, I didn't know that. Thank you for sharing it. So those of you that didn't complete the simulation, please go with the computer, close somebody that completed the simulation, and let's arrive to a point that everybody has completed the simulation. Because we have to do another simulation after that. So I leave you 20 minutes now. It's 11:40. Before 12, everybody on the computer needs to have Google Earth with one simulation on it. I will pass to see your computer in 20 minutes. Enjoy. Work together. Let's act like a class. Once you have, okay, good question. Once you have added the simulation, you go on the left side of
Eccomi.
Google Earth and you have the layer here.
Infatti, la seconda domanda è stata: quali attività far svolgere ad alunni che vogliono entrare nel mondo dell'imprenditoria sociale?
Che cazzo di domanda
Uno
è?
lasciava il microfono aperto, ragazzi. So guys, Clementina, you go here on the left where you find now a new layer that is called hotspot. You unbox it and you hide it. You box it and you have it. So you can hide or you can do, I don't know, 15 scenario and then those are in the system. You can just hide the layer, okay? And it is very useful because sometimes when I want to see the overall damage of a simulation over an area, changing the wind direction, I record a video, I open a layer per time, and I record the video and I put the video on the presentation. E li fa risparire poi. Lo fai a mano, è gratis, sempre lì la cosa. The advantage of this system is that Google Earth is free of charge and Hotspot is free of charge. Now we put on Google Earth, guys, the simulation, but each one of you in your home country, if you go on the governmental site, you can download the data that can be georeferenciated, referring to number of population per city, number of hospital, number of police station, number of firefighter station. You can add all this information and drag it and design it on Google Earth. So once you have this area with the simulation, you can open the layer of the other information, colored, and you can see a certain area that is affected from the simulation. What is the density? How many people are there? How many hospitals are there? So you can build up a graphical database and you can use it actually during an emergency for free. It is done, this work, from a company in Italy, Estri, for instance. Okay, they take a lot of money to do it for the civil protection, but with tons of patience and 30 days of work, you can create your own national database and you can use it for free. You have not to pay to do it. Those are all free of charge information. C'era qualche domanda da casa nel frattempo che loro fanno la simulazione? Somebody had some question from home? No? Okay. So try to reach the simulation georeferenciated on Google Earth. Thank you. Another piece of information, if you click on the layer of the simulation, hotspot version 3.1, you can change the name, of course. I can call it simulation on Sette Frati. And if you click on it, it gives you the value of the contour level. So remember, everything is in the red area, is higher than 1 to -8 sievert, okay? We put very low value. This is why the plume is so big. Usually we should put here 1 millisievert, 100 millisievert, 20 millisievert, 1 millisievert. So we put the value for Italy from the Italian legislation. Red area emergency value 100 millisievert. Exposed labels 20 millisievert, population 1 millisievert. La 101 del 2020 ci dice 1,20 100, è una tabella però vale per l'Italia. Solo per l'Italia, perché la Commissione di Radioprotezione Internazionale, il CRP, ha dato delle linee guida alle nazioni che sono nella IAEA. Queste linee guida hanno dei range. Ci sono paesi più conservativi come l'Italia, paesi meno conservativi come l'America, ma comunque stanno tutti quanti, tutti nei range. Chiaramente se noi andiamo a fare una simulazione in Italia ci usiamo la nostra legislazione di riferimento. Se la dovessimo fare in Europa dovremo o provare a fare delle simulazioni nei range, cioè nella parte più alta e in quella più bassa, o metterci nella legislazione del paese in cui stiamo simulando l'evento. I lavoratori esposti 100 come quelli che lavorano nei mercati, per loro hanno la popolazione comprende 20 e i lavoratori esposti che lavorano in emergenza sono al centro. Siamo noi che abbiamo fatto il primo che mi viene in mente, poi finalmente ogni nazione può avere uguali, un po' diversi, però siamo sempre lavoro al centro. Però cambia questo. In some of these modules, like you have to do 3 simulation right away.
11.
Ciao girando
Now you can it's another effective source. Remember with the name you prefer. I don't remember where you are saving the file.
I don't think it's No.
If the name of the place where was born. Okay, close. Okay, now the file you have on the desktop in no, close. We have to minimize the screen. Okay, but minimize this. Search the file here, simulation. Okay. We have to change setup. Okay, color options. It's red, it's okay. Yeah, it's orange. The last one, yellow. Okay.
Sono meglio. Ora sto scaricando se vuoi dire quella blotta deve
non è proprio uguale, quindi avremo una mappa di ispezione che sortiamo qui. Così, sicuramente poi vedete poi un po' più scritto da usare l'esterno per la parte teorica. Fate stare una giornata sì, perché ci sono dei momenti in cui la computer lascia un po'.
Yes.
Ma per fare la georeferenziazione facciamo l'uso di ma sarebbe il software di georeferenziazione che sta dentro il pacchetto camera, è quello che ha lo no, noi ce la facciamo direttamente con
Mezzo al mare, diciamo che è arrivata diciamo che non è un'emergenza.
hai ammazzato uno studio
va bene, ma io dico così più grossi per esempio facciamo le riviste chiediamo fare il rispettare i nostri contenuti. Poi se casa scritto, ci vedi,
Ah, ok.
Quello grafico per cui c'è
a 7 ore. Ho pensato, guardo la data, vabbè, sì,
C'è tu sai,
Okay, guys, let's drop a nuclear bomb, and then we go to launch prep. Okay. So let's go and let's do a nuclear explosion. Do not close Google Earth. Leave Google Earth open. Stiamo registrando e sì, ok. Leave Google Earth open, just reduce the screen. Go again on spot. Go on model and click on nuclear explosion. Once you click on nuclear explosion, you have just one tab to fill. So for the general explosion, you have to fill 6 tabs. For the nuclear explosion, it's just one. Most important information you have to put is nuclear yield. So how big you want this. Here we have 1.5 megaton. Why there is 1.5 megaton, which is 1,500 kiloton?
You simulate a nuclear bomb like Trinity.
It's quite common, let's say, nuclear bomb in the arsenal in the world. Almost everybody has at least one bomb that is 1.5 megaton. So let's leave this. Let's do not leave this value. Let's go with another value. Let's go with 100,000 kiloton. Hundred.
Is too much, Andrea.
Too much?
Yes, you have the limit here on the screen. That is
Okay, you are right.
range.
50,000 kiloton. Let's go with 50,000 kiloton, which is the maximum that has been exploded in a real experiment, which is the Tsar bomb. 50. Ah, la virgola vuoi. Let's try in that way. Not changing. No, it's not changing. I don't know why. Let.
50,000.
Ah, okay. Okay.
No.
Okay. Okay. So write the number, just 50,000, okay? Then wind velocity 4.6 meter per second. We put in the other simulation 5, so more or less is the same. Wind direction, let's go wind from east. Here you have, as you can see, the fallout dose is in REM, not in sievert. By the way, you have to remember 1 sievert, 100 REM. Okay, so the software has set the highest value. The other part, in the other simulation, we had 1 to -8. Here we have in sievert 1, 1. So we have 10 sievert, 1 sievert, 0.1 sievert. So we have very highest value. And the other interesting thing is that you can simulate the shielding that you have. So no shielding, 1 meter underground, frame house, basement, multi-story upper store, multi-story lower floor. Let's put no shielding. And then you can set the picture of the simulation after a certain time from the explosion. So those in first hour, those in the first 6 hours, those in first day, those in first 4 days, and so on. Let's go with those in first day, okay? Once again, we have to set the location. So set the location. Let's go with Settefradi again. Give me the number from Settefradi. I cannot remember it. 41, then 40, 11, 75 north, 13, 51, 02, 38 east. 36, okay, east. Okay, return. At this point, you click on Fallout contour file. You save it. as explosion atomic bomb, and you drag here, and that's the results of the explosion. Now, do not be tricked by one data. Now I will remove the layer that is under the one of the nuclear explosion. Why? Because the limit that we put in the previous simulation are 10 million lower than the one that we put for the nuclear bomb. So if you want to compare the plume of the simulation, you need to use the same threshold, okay? So this is basically the results that you have for such a kind of bomb. Basically, the 20% of Italy is affected from an explosion like that. And this is not the worst bomb, let's say, the bomb with more energy that we can drop, because this is 50,000 kiloton, but it can be used up to 100,000 kiloton. So you have to consider that you can have something in terms of energy that is double the simulation that we have done. So this is basically why, okay, now you see the contamination area. This is basically why nobody wants to start an atomic bomb, because you can drop an atomic bomb, but then you will receive an atomic bomb. And this is the damage for your population. This is the damage in terms of, for instance, of contamination. And the contamination do not affect only the persons, affect also the environment, affect the food, the water, the animals that we eat, the milk that we eat every day. So in terms of damage, there is not only the explosion one and the direct contamination on human being, but also all the collateral contamination damages coming from the fallouts that can have a duration of decades, even decades. So the simulation part is easiest regarding the special purpose for the nuclear explosion. Then you close this tab and it reports you again on the main one, okay? So now what I do want is you using a 50 kilo dirty bomb charged with the strontium 90. So I give you all the so this is the substance for the dirty bomb. Then 50 kilo of explosive. Vatican City. So see how good I am. I kill my mother and my father and then my pope. I want everybody to feel welcome in the room. So, Vatican City, 50 kilo of explosive, strontium, today, now. Do the simulation and do the georeferenciation. All the rest of the data, you can add it by yourself. The media data, you can take it. The receptor, if you want, you can use the default one. Make the simulation, extrapolate the TXT file, and put not only the output, what do I want? I want graph you decide it. If it is not requested, you decide it. Graph of doses on Google Earth graph of ground deposition on Google Earth. So I want you as an exercise to do the simulation and get this. I will leave the data here. You have till you have 30 minutes to do it. Okay.
Andrea,
30 minutes
so
and
you,
then
what about the material at risk in this case? We have to choose by ourselves.
I will not tell you you have to choose by yourself or you leave the default one. When the data are not given, even in the homework of Friday, you have to choose by yourself, but you have to justify it. So all the other data you have to choose by yourself. So you can leave the default one, or if you change the default one from the software, you have to explain why, okay?
Quando clicco qua per modificare input values must be right now e non mi fa fare nulla
Perché prova a modificare il testo. Boh, non lo so. Quando fa così, comincia a fare così, devi disinstallare e installare il software.
cioè che va poi in
Veramente non potrebbe dare, for the contour value, you have to select what contour do you want to put on the graph. You can leave again 1 to -8, 1 to -9, 1 to -10, or you can change it, okay? You have to change it here. If you want to do this here, change on here, we change it.
però io adesso voglio mettere sai nel senso che se non è è prima agevolata può essere 4 o 10 della dichiarazione di immagine quindi siccome sono pratiche
Ma molto più diverso,
Quindi c'è un aiuto.
Poi non ci sono
You can choose whatever you want, right? Okay. When to change the with
Guarda, è più realistico quello dell'inverno nucleare. Ma che è lo split payment? Noi pagheremo 12.200 euro, basta, deve fare una fattura unica, 10.000 euro più 22% di IVA. Stop, e gliela paghiamo, non è mica soluzione. Ok? Poi la settimana prossima cominciamo, la fattura la puoi mettere anche subito, il documento è in firma. You finish. No, it's minus.
Okay, probably use this the error before because the different from
Sono 40,36 basso, invece
il resto avete lasciato tutto uguale? This is something that checking with the guy. Avete messo ok? Cambia solo questo.
Cioè, deposition che
Okay, now we have the
è questo.
Okay, so location.
Anche 94. Forse questo, chiamiamo di cose questo è il primo. No, because you you want to exit? Questo no. Vatican One. Che prendiamo questo? C'è il centro che mi suppone che di posizione sempre un film
Eccolo, guarda, se lo cancelli
No, devi girare.
Now we are in see the solid
So guys, did you complete the simulation? Everybody complete the simulation? Okay, lunch break. See you at 2 p.m. Bye. Colomba, vado a pranzo pure io.
Ok, fermo la registrazione.
Sì, ok. A dopo. Ciao.
A dopo.